So in this video, we're going to talk about moles and molar mass. So this is topic 1.1. So in this topic, we want to calculate quantities of a substance or its relative number of particles using dimensional analysis and the mole concept. So we're going to review some things that you probably remember from your previous chemistry class. So first, I want you to remember that oftentimes when we're talking about substances, whether it's compounds, atoms, whatever, general term particles, we often need to know how many there are, not necessarily what their mass is. However, they're so tiny, we can't actually count them. Therefore, we have to count by weighing them or count by knowing their mass. So they're either too small or too numerous to count. So we can use an average of a single item to determine the total number of items. So two examples, one non-chemistry related, jelly beans. Okay, so let's say you have a jar of jelly beans and somebody says, I want to know how many jelly beans are in this jar. Well, if you happen to know the average mass of one jelly bean, you can take the total mass of all the jelly beans, divide it by the mass of one, and that will tell you how many there are. We use the same thing with molar mass. If you know the total mass of a sample and you know the average mass of one part of the sample, so whether it's the average mass of a compound or an atom, whatever it is you're looking at, which is the molar mass, you can divide them and you can figure out how many there are. So we're going to use that a lot later when we talk about chemical reactions and we need to compare numbers. Okay, so as a reminder, each element has an average atomic mass. Okay, so this average atomic mass is a weighted average of all isotopes. We're going to come back and we're going to talk about that in more detail in a later unit when we talk about atomic structure. And the sum of the masses of the elements in a compound will be equal to the mass of the compound. Okay, so this is just where you're adding up all the parts. If you have one sodium and one chlorine, the mass of your sodium chloride is going to be the mass of the sodium plus the mass of the chlorine. Okay, and that tells you your molar mass. That mass is specifically the mass of 1 mole of that substance. Okay, so therefore you know the average mass per 1 mole. Okay, so we have to review what a mole is. Okay, moles are used to count atoms, molecules, particles, really, really tiny things. Because they are so incredibly small, we use a really big number. Use Avogadro's number. And the one that we use in AP chemistry is 6.022 times 10 to the 23rd. So 4 significant figures. 6.022 times 10 to the 23rd. That's going to be a number you're just going to want to know. Okay, so 1 mole, it doesn't matter if it's a mole of an element, molecule, whatever, a mole of anything is 6.022 times 10 to the 23rd. My favorite example are rocks and bagels. If you have a mole of rocks, it means you have 6.022 times 10 to the 23rd rocks. If you have a mole of bagels, you have 6.022 times 10 to the 23rd bagels. It's a ridiculous amount, okay? You might remember from a previous class, you may have done it, you may not have, you drew dots and we calculated how long it would take you to draw a mole of dots. You couldn't do it in your lifetime. You can't draw dots fast enough to be able to, even if you spent your entire life from the moment of your birth to the moment of your death drawing dots, you still wouldn't be able to draw a mole of dots. It is a ridiculously huge number, but we use it because particles are so incredibly tiny. Now, one thing that we don't usually talk about much until we get to AP is using a compound to think about moles of atoms. Okay, so we have 3 examples. So if we have a mole of sodium chloride, it means that you have 1 mole of sodium atoms and 1 mole of chlorine atoms. So you have 2 moles of atoms total and 1 mole of the compound. Sometimes it's hard to wrap our brains around because 1 doesn't seem like it should be equal to 2. It seems like you're making stuff. But remember, when you split this up, for every 1 sodium chloride, you have 2 pieces. So if you split it up into its pieces, you have a sodium and a chlorine. So 1 sodium chloride gives you 1 sodium, 2 chlorine, 2 atoms. H2O, water. So we've got 2 hydrogens and 1 oxygen. So if you have a mole of water, that means that you have 2 moles of hydrogen, 3 moles of oxygen, total 3 moles of atoms in your 1 mole of the compound. And our last example, C6H12O6. So again, 1 mole of this compound gives you 6 moles of carbon, 12 moles of hydrogen, 6 moles of oxygen. Okay, in just 1 mole of that compound, because we're thinking about how we split all those pieces up. Now, what's useful from all of this, despite having the general concept, what's useful is being able to convert. Okay, so anytime we go between mass and moles, we're going to use molar mass. Okay, that makes sense. The word itself, molar mass, it's going to go between moles and mass. Okay, when we're going between moles and particles, that's when you're going to use Avogadro's number, because that number tells you how many particles there are in a mole. Okay, so you'll see that referred to both ways. Now, the units here are important because it kind of guides your math a little bit. Molar mass, remember our units are grams per mole because it's the number of grams in 1 mole of that substance, or the mass per 1 mole. So grams per mole, or G/mol. And then Avogadro's number, its units are particles per mole. That's the general term because they're not always atoms, they're not always molecules, they're not always compounds. So it's particles per mole. So we're going to want to use those units to guide whether we're going to multiply or divide it to be able to get to our number. So if you're going from mass or grams to moles, you're going to want to divide by your molar mass. If you're going from moles to grams or mass, you're going to multiply by your molar mass. Did I say that correctly? Yes. I'm doing mental math while we're doing this, going through my unit conversions. Yes, that's correct. If we're going from grams to moles, you want to divide because you want your grams on the bottom. If we're going from moles to grams, you want grams on the top, so you're going to multiply. And then when we're dealing with moles and particles, when you're going from moles to particles, you're going to multiply by Avogadro's number. That should make sense because our moles number tends to be a little bit closer to 1, whereas our particles are going to be really big. Okay, so you should have a really big number for your numbers of particles. Going the opposite direction from particles back to moles, you're going to divide because it should give you a smaller number. So you should be taking a really big number when we're looking at massive numbers of particles. Divide by Avogadro's number, it should get you to a more reasonable number for the number of moles, which is why we use moles in the first place, so that we're not dealing with ridiculously huge numbers.